Hello students, good morning to all. Welcome to your beautiful channel Firjan. Today we discuss current electricity, third lesson 12th standard. In this one, we discuss about cells, how to connect in series, parallel, what are the related problems, mixed group means parallel connection, series connection, combination. So that now we discuss. See here, what is the lesson name now? Current electricity. Current electricity, third lesson. See here, in this one we discuss first cells. Cells in combination. So means series combination, parallel combination. See, cell is energy supplied source. Energy supplied source. It provides electrical energy to the circuit elements. Whatever the in the circuit elements is there, like capacitor, resistor, motor, whatever devices is there in circuit, for that it provides electrical energy. Means cell provides electrical energy to the circuit elements, means it provides electrical energy. So how to represent now this one? See, one long line, one short line, it is the representation of cell. See, one long line is plus, short line is minus, with internal resistance is there here. See, it is the smaller, it is the represent, actually it is the representation of cell. So long line, short line. So means in cell does not change, the cell does not change the charge, it provides electrical energy to the circuit elements. In this case we discuss two types of combination is there. One is a series combination and a parallel combination. So first we discuss a series combination. It is the cell na positive negative terminal. We can take one more cell. See here, it is a positive, it is a negative, internal resistance or see, negative terminal of first cell is connected to positive terminal of second cell. Negative terminal of second cell is connected to positive terminal of third cell. This combination we call it as series combination. See once here, cell means energy supplied source which provides electrical energy to the circuit elements. Whatever the circuit elements in the circuit, it provides electrical energy. It does not change the charge, it maintains constant potential difference which forces the electrons or charges in the circuit. Yes, na? It converts chemical energy to electrical energy. Cell provides electrical energy. How now it has chemicals is there, it will convert into chemical energy to electrical energy. That is the basic information. See again, cell means energy supplied source. It provides electrical energy to the circuit elements. So it does not change the charge. It only carries the charge. It means it maintains potential difference, constant potential difference, and move the charges in a circuit. It converts chemical energy to electrical energy. It is the symbol. See here, it is one cell, second cell, third cell. Means we can write here E1 means energy. So means electromotive force, EMF. See, it is E2 energy 2, E3 energy 3. Means first cell E1, second cell E2, third cell E3. These are connected in series. Series connection now we can say end to end connection. End to end connection. Series connection of cell. It is series connection. See here, series connection means negative terminal of first cell is connected to positive terminal of second cell. Negative terminal of second cell is connected to positive terminal of third cell. This combination we call it as series connection. In this one, see here, this is the terminal A, means it is connected to A, it is connected to B. See here in this one, current is moving this direction. So before going to discuss this series combination, we discuss first KVL. KVL means Kirchhoff voltage law. By using this, we can find the what is the equivalent EMF when cells are connected in series. What is the equivalent internal resistance when cells are connected in series. So for that, the KVL means Kirchhoff voltage law. Kirchhoff's voltage law. See, Kirchhoff voltage law means the algebraic sum of change in potential around a closed loop is 0. Around a closed loop is 0. It is the Kirchhoff voltage law. Actually, two laws is there: Kirchhoff circuit law, Kirchhoff voltage law. We discuss later. Now we have this one, so we use this one. See, Kirchhoff voltage law means the algebraic sum of change in potential around a closed loop is 0. Means that we can write mathematically summation delta V equal to 0. In a closed loop, whatever change in potential across devices, that change in potential, sum of change in potential is always 0 in a closed loop. That we can write. See here, closed loop na this one. See, plus or minus V1, plus or minus V2, plus or minus V3, so on, plus or minus Vn equal to 0. It is the Kirchhoff voltage law. See, in this one, some rules is there. First one, see, it is the positive terminal of cell. It is the negative terminal of cell. See here, loop direction. This is the direction of loop. Loop is moving from higher potential to lower potential. So plus means higher potential, minus means lower potential. It is moving from higher potential to lower potential. Such case, potential drop is there. Potential drop. This potential drop we can write it as delta V equal to minus. So we can take it as negative. So means potential drop when it will happen na, direction of the loop is from higher potential to lower potential. That case we can say that potential drop, that is delta V equal to negative. See, for example, second one. So it is the positive, it is negative. See here, direction of loop is first touches negative terminal. Negative to positive is there. Means negative means lower potential, positive means higher potential. So means direction of loop is lower potential to higher potential. That case, potential gain is there. Potential gain. So potential gain we can represent delta V equal to plus positive. Delta V equal to positive means change in potential is positive. See here, loop direction of loop is negative to positive. Negative means lower potential, positive means higher potential. Lower potential to higher potential direction is moving na loop direction. That case we can take potential gain. So potential gain we can write delta V equal to positive. Delta V equal to positive. See third one. Here see third one. It is the resistor. It is the direction of current. See here, this is the direction of loop. This arrow mark indicates direction of loop. This arrow mark indicates direction of current. See here, direction of current na higher to lower potential. Higher to lower potential. So see, higher potential to lower potential na loop is here first touching lower potential. So lower potential touching now what here? So positive. Here also means potential gain. So means delta V equal to what we can write now here positive. In the same way we remember direction of current is leftwards. Direction of loop is rightwards. Both are in opposite direction. When current direction and loop direction both are in opposite, we can say positive. Or otherwise, current is always moves from higher potential to lower potential. So higher to lower. So loop is moving lower to higher. So opposite is there. Means touches first lower to higher. So means potential gain is there. So potential gain means delta V equal to positive. See here fourth one. See here, it is the current direction, means it is the direction of current. It is the resistor. See loop direction, both are in same direction, means current direction and loop direction. Current direction is how it is, higher to lower. See higher to lower means potential drop. See here, same current and loop direction are same, potential drop, that we can write negative. These are the rules. While we derive an equation for series combination and parallel combination, these rules we can use. So that's why we discuss this one. What is Kirchhoff voltage law? The algebraic sum of change in potential around a closed loop is always 0. Always 0. Always 0. It is the statement of KVL, means Kirchhoff voltage law. See what now? Positive to negative. Positive means higher potential to lower potential is the direction of loop. potential drop is there. Potential drop na delta V equal to negative we can write. So lower to higher potential is there, loop direction. So we can write potential gain, that is delta V equal to positive. See here, this is the direction of current, leftwards is there, loop direction rightwards is there, means direction of current is what, higher to lower only. So here see loop, first lower to higher is there, lower to higher means potential gain. So delta V equal to positive we can write. In one more, both are in opposite direction, current direction and loop direction, so we can write positive. Both are in same direction, negative means higher to lower, loop direction is higher to lower na, what are delta V equal to minus. Why? Because potential drop is there, that's why we can write negative, positive, negative. Here negative, positive, potential drop na negative, potential gain na positive. This is the Kirchhoff voltage law. See here, we discuss now here, derive an equation for series combination of cells. It is the series combination of cells. See here, it is the loop direction we can take. Yes na, see first touches positive to negative, positive to negative means, so means higher potential to lower potential na, potential drop negative, we can write minus E1, minus E1. See here, here potential at A, now we can write potential at A is VA, sorry, see VA minus potential at E na, potential across cell na, here see it touches positive to negative, means direction of loop is positive to negative, we can take minus. Why? Because higher potential to lower potential na, potential drop, we can write minus. So that way delta V equal to minus E1. So VA, here potential at A is VA, potential at first cell is minus E1, potential across this resistor na, see here direction of current is right, leftwards, direction of loop is rightwards, means current is moving from higher to lower. Here higher to lower means up, means when current is moving higher to lower na, direction of loop is lower to higher, what we can take na, plus. Yes na, so or otherwise, so direction of current and loop are both are opposite direction, opposite direction now we can take positive, potential gain, so positive. Here see what is the potential across R na, here R1, here R2, here R3. See R1 na, here V1 equal to what we can write na, potential equal to current into resistance. What is current here? I current. Yes na, current is I. So means we can write I R1. So here write here I R1. Yes na. So potential, change in potential across resistor R1 is I R1. See now here this one we can take here. See, it touches positive to negative, so means direction of loop is positive to negative is there, means higher potential to lower potential, we can write minus E2. Why now? Here potential drop is there, higher to lower is the direction of loop is higher to lower, minus. See here, it is the direction of current, both current and loop direction opposite, we can write here plus I R2. Why? Because potential equal to I R2. Yes na. See this one touches positive negative, so means higher to lower, loop direction is higher to lower, means we can write minus E3. Yes na. So next na, here what is the potential here? V3 I R3. See here we can write plus I R3, that equal to potential at B is VB. See here, while using KVL, touches positive to negative na, we can take minus. So loop direction and correct direction both are in opposite, we can take plus. See here, this is the direction of current, this is the direction of loop, so means plus. Here see positive to negative, touches first positive terminal of the cell, so we can take minus. See here, here positive to negative, so that's why we can take minus E3. Here R3, across R3 now, V3 equal to I R3, I R3 y plus we can take now. Here this is the direction of current, this is the direction of loop, so we can get I R3 equal to VB. See VB is changes to this side, this remaining will be changes that side, means VA minus VB equal to this one changes that side, means plus E1 minus R1 IR1 plus E2 minus IR2 plus E3 minus IR3. It is the potential. See change VA minus VB, we can write V. See here E1 plus E2 plus E3. See minus of I common, R1 plus R2 plus R3. This we can get. See here, change in potential equal to E1 plus E2 plus E3. minus of I into R1 plus R2 plus R3. Here now how it is now is this one, V equal to E minus IR. So means here E effective we can write, R effective we can write. See, terminal voltage equal to electromotive force, EMF minus I into R effective, means here E means energy, electromotive force, effective electromotive force or effective energy, and I means current, R effective means effective resistance, internal resistance. See, it is like that na, it is E, it is IR. So we compare here, E effective equal to what here, E effective equal to E1 plus E2 plus E3. R effective equal to what now here, see, R1 plus R2 plus R3. It is the R effective, it is the E effective when cells are connected in series. See, when cells are connected in series, what we are getting now, effective EMF E1 plus E2 plus E3. Effective resistance now, internal resistance now, R1 plus R2 plus R3, R1 plus R2 plus R3. See here in this case, this is the series combination. In this case, what is effective EMF now? This one. Effective resistance, this one. This is the method to find effective resistance and effective EMF when cells are connected in series. So these formulas we can remember and apply to the problems. See here, it is the series connection. When we can say series connection, negative terminal of first cell is connected to positive terminal of second cell, negative terminal of second cell is connected to positive terminal of third cell. That combination we call it as series combination. In series combination, for finding effective EMF and effective internal resistance, we use Kirchhoff voltage law. We know algebraic sum of change in potential around a closed loop is zero. For that, potential drop na positive, negative, potential gain na positive. Potential drop when higher to lower move na potential drop, lower to high move na potential gain. See here current, both are in opposite direction, positive, same direction, negative. So by using this, we can find out, so effective EMF and effective resistance. Yes, now see, next we discuss some problems according to this series combination. See, for example, before that, one more is there. Polarity change means what happened, that also we discuss first. See here, polarity change means if polarity of cell is changed, polarity of cell is changed means, see here, it is the plus minus, here internal resistance is R1. See, it is connected negative positive, so this is called polarity changes. So means polarity of cell is reversed. That case, what is the effective EMF, what is the effective internal resistance? See, for example, it is A, VA, it is B, means VB, means at this point what is the potential now, VA, at this point potential is VB. So this case, it is E1, it is E2, it is R1, here one more resistor is there. See here, it is R2, so it is VB. See here, if polarity of cell is reversed, polarity of cells are reversed, what is the effective EMF and effective internal resistance? For that, see here, what now, this is the direction of loop, it is the current direction. So what now, positive to negative, we can write first this one, potential at A is VA minus E1. Yes, now why? Because positive to negative, potential drop is there. So here, see, current direction, this direction, loop direction is opposite, so we can write here plus I R1. What is the change in potential across the resistor R1? I R1. See here, negative to positive. Negative to positive, na, what we can get here? Potential gain, positive, E2. Next here, same, opposite direction, current and loop direction. So we can take here I R2 equal to potential at B is VB. So VB changes this side, means VA minus VB equal to E1 minus I R1 minus E2 minus IR2. See here, what now here, E1 minus E2 minus of I R1 plus R2. Now see here, so VBA minus VB we can write V. So means here how it is, V equal to E effective minus I R, means effective. See here, E effective means here E1 minus E2, E1 minus E2. R effective means here R1 plus R2. It is the effective resistance, it is the effective EMF. See, when the polarity of cells are reversed, so polarity of cells are reversed means E1 minus E2. Effective internal resistance is R1 plus R2. Yes, na? So when cells polarity of cells are reversed, it is the effective EMF and effective internal resistance. So before we discuss, cells are normal connection means not reversed, polarity is same. That case, effective EMF equal to E1 plus E2 plus E3 so on En. Internal resistance R1 plus R2 plus R3 so on Rn. Yes, na? So now we discuss the problems. See, first problem, see, find the effective EMF and effective internal resistance when cells are connected. See, first problem, see here, it is the connection. This here A point, terminals, B point, it's a potential is 6 volt, 4 volt, 3 volt, it is 1 ohm internal resistance, it is 2 ohm, it is 1 ohm. Yes, na? See here, it is the direction of current. It is the direction of current. Now see here, find effective EMF and effective resistance. We want to find effective EMF and effective internal resistance. What is the formula here actually? So we effective EMF equal to what are here E1 plus E2 plus E3. Here 3 cells is there. So effective EMF now here what 6 volt plus 4 volt plus 3 volt. What we get now here 13 volts. What is the effective EMF now? 13 volts. See here effective internal resistance now. See effective internal resistance 1 ohm plus 2 ohm plus 1 ohm. Why now here effective internal resistance equal to R1 plus R2 plus R3. Yes, now that's why 1 ohm plus 2 ohm plus 1 ohm means what we get here 4 ohms. What is the effective internal resistance now? 4 ohms. 4 ohms. Yes, now this is the solution for this one. So what is the effective EMF? E1 plus E2 plus E3, that is 13 volts. Effective internal resistance is 4 ohms. Now see here, for example here, next problem, if n cells of n cells of each EMF, each EMF E and internal resistance are connected in series, connected in series. See, if n cells of each EMF E and internal resistance are connected in series, connected in series, and external resistance, external resistance capital R is connected to combination, connected to this combination, if polarity of M cells are reversed, then find current in external resistance. External resistance, what is the current that we find out? See here, what is the problem now? If n cells of each EMF E and internal resistance are connected in series and external resistance R is connected to this combination, if polarity of M cells are reversed, then find the current in external resistance. Then find the current in external resistance. We want to find out what is the current in external resistance. So that is, see here, for example here, see, I write now here, so n cells. See, for example, is the cell here, see, 1, 2, 3, so on. So how many cells here? N cells are connected in series. Each of EMF is E, here also E, resistance is R. That is the connection. So what they said now, N cells are connected in series and external resistance R is added to this combination. After that, if polarity of M cells is reversed, what is the net current in the circuit that we want to find out? See, these are connected in series na. What is the effective EMF? So effective EMF equal to E1 plus E2 plus E3 so on N En. Yes na. See, effective EMF na, here all same magnitude, E plus E. How many is there here? N cells is there. N cells means what is the effective EMF now? See, Ne. Effective EMF is Ne. Effective resistance now. See, effective resistance is what? R1 plus R2 plus R3, R2 plus so on Rn. So means what is the effective resistance? R plus so on N Rs is there. So means what we can write here? R effective equal to NR. What is the effective resistance now? NR. Effective internal means energy means EMF is Ne. So these are connected in C. It is the cell. It is connected to. So means external resistance. It is the external resistance. See here, it is the external resistance. It is Ne. It is Nr. So means effective EMF is Ne and effective internal resistance is Nr and external resistance is R. It is connected to circuit. So means external resistance R is connected to circuit. This case current is I. See, one more condition is there here. If polarity of M cells are reversed, M cells are reversed, then find the current in the external resistance. For example, see, we have 6 cells is there. For example, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 is there. Yes, these are we have. What they are saying now, for example, we discuss. So one cell is reversed. Means one cell, polarity of one cell is reversed. Means one cell reversed means we can remove this one and connected. See, like this I connected. Second one, third one, fourth one, fifth one. See, one cell is reversed. Reverse polarity is reversed means, so means lower potential first, higher potential later. See here, this one, it is the circuit. See here, how now here what is the resultant now here? E means here I write, see E1, sorry, E, 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 E. Now we get what now here? See, E effective equal to E1 plus E2 plus E3 plus E4 plus E5. Here minus now E6 now here polarity is reversed means we can write minus. So what we get, this plus E minus E cancel. What we get, 1, 2, 3, 4E means effective EMF equal to what we get, 4E. So means how we are getting here, take totally how many we can take, 1, 2, 3, 4, 5, 6 cells we can take, we are getting 4E means we can remove one cell. Total is how many is there? 6 cells is there. One remove means 6 minus 1, 5. So that again what we are doing? Polarity change. Polarity change means 5 minus E. Again what now? 4 we means how many we are subtracting now? 2 we can subtract totally. Then we can get the effective EMF. Means here what is the effective EMF now? If M cells are connected reverse means that case effective EMF equal to total EMF is Ne. So means M cells are reversed. We can remove minus Me and again added it will be polarity changed means again minus Me means totally what we can get here, Ne minus 2Me. It is the effective EMF when cells are connected in series. N cells are connected in series and M cells are, polarity of M cells are reversed. That case what is the effective EMF now? Ne minus 2Me. Ne minus 2Me. Now see here that we can take effective EMF. We want what is the current in the external circuit? External circuit. That means I equal to what? Net EMF by net resistance. Net resistance. See here, net EMF is what here? Ne minus 2Me by net resistance now here. resistance is N R, external resistance is R. So both are in series combination. Series means just added. So N R plus R. It is the current in the external circuit is what now? N. Here we can write common E. So N minus 2M into E by NR plus capital R. This is the current in the external resistor. When cells are connected, N cells are connected in series, if polarity of M cells are reversed. That case, this is the resultant. First see here problem. If N cells of each EMF E and internal resistance are connected in series, and the external resistance R is connected to this combination. See, if polarity of M cells are reversed, then find what is the current in the external resistance. Means our external resistor, external resistor, external resistor. See here, M cells, first N cells are connected in series. What we get? Effective EMF NE, effective resistance na NR. See, if M cells are reversed, M cells are reversed means, for example, here we can take 6 cells. One cell is removed and connected, polarity changed. So means here removed means -1. So means 6 minus 1, 5. Again it will be reverse. Reverse means again minus only na. Polarity change means minus we can write. So means already 5E we can get resultant. So 5E minus 1E means 4U we can get. Means here when one cell is connected reverse polarity means we can subtract 2. So means here M cells are polarity is reversed. So that means we can remove ME and again their polarity change na. So again we can write minus ME. So we can write what now here NE minus ME means minus 2ME. So NE minus 2ME is the effective EMF and effective resistance is NR. Effective resistance is NR. See, we can write I equal to net current in the external circuit is net EMF by net resistance. What is the net EMF here? Net EMF means NE minus 2ME and net resistance na here NR. Where net resistance is NR. So means we can write NE minus 2ME by NR net resistance. Here our external resistance is R. Both are in series na, NR plus R. So means NR plus R is the net resistance. So means what we get now here? E common N minus 2M into E by NR plus R. It is the current in the circuit. N cells are connected in series and external resistance are connected to the combination, and if polarity of M cells are reversed, that case what is the current in the circuit now? Formula shortcut is I equal to N minus 2M into E by NR plus R. Here N means cells are connected in series, M means polarity, M cells, polarity of M cells is reversed, that is M here. So NR na effective resistance, internal resistance, capital R na external resistance, E means EMF, each cell. Yes na? See, this is the solution. Now see parallel combination, we can discuss parallel combination of cells. See, parallel combination of cells. Series over na, so parallel. So parallel combination of cells. Parallel combination of cells. Parallel combination of cells. See here parallel combination means, see it is the cell, long short line. So long line is positive, short line is negative. Internal resistance R1. See one more cell here, see it resistance is R2, EMF is, it is E1, it is E2. See first two terminals means positive terminals connected to fixed point, connected to fixed point. Here see A. So this negative terminals connected to fixed point B. Current is moving from B to A. This is the direction of current. Here see current I na, in parallel combination of cells. Parallel combination of cells means all positive terminals connected to fixed point, all negative terminals connected to fixed point, then the combination is called parallel combination of cells. In parallel combination of cells, here see current I, here it is divided, here I1, here I2, I1 I2 divided, again here combine and come out with I. So this is the happen in the parallel combination of circuit. In this case we can take loop, means by using Kirchhoff voltage law we can find the effective EMF and effective internal resistance. See for example that one we can take, we can select one loop. That loop is here, this we can take a x y b. I take here loop. What is the loop now here? A x y b, it is the loop. So in this loop, so we can, so what is the loop direction now? This is the direction of loop. Yes na? See, I draw here. See, it is internal resistance, it is, see, it is the loop direction. See, it is a point, b point, it is the current direction I1, it is R1, it is E1. See, it is the direction of current. This loop now, this is the direction of loop. Yes na? See, first we can write, so it touches positive to negative, moving, loop is moving from positive to negative. Positive to negative means potential drop. Potential drop means this is E1, it is R1, so means minus. So potential at A we can write A minus E1. See, across the resistor R1, what is the potential now? V1 equal to I1 R1. See, here we can write, so now here this is the direction of current, so loop direction opposite is there, so we can take I1 R1 equal to VB. Again listen here, so we can select one loop. So I select A X Y B. So in this one A X Y B, so direction of current is B to A, loop is A to B moving. So that case loop moves from higher potential to lower potential. Higher to lower means potential drop is there. Potential drop means we can write minus E1. Here potential at A is VA, potential at cell is minus E1, potential at R1 is I1 R1. So I write here I1 R1. Why we can take plus now? This is the direction of current, it is the loop direction. Both are in opposite, so we can take plus. See, potential at B is VB. It will changes to this side. VA minus VB equal to E1 minus I1 R1. It is the potential across the cell. Yes na? See, this one E1 minus IR1. See, this VA minus VB we can take it as V, that equal to E1 minus I1 R1. This I1 R1 it changes to this set. What we can write here? I1 R1 equal to E1 minus V. So I1 equal to what we can write now? E1 minus V by R1. It is the current in the circuit when cells are connected in series. I1 we can find out. Next I2, similarly this loop we can take na, this A, this one na P, Q, B we can take. Same we can take here, what not, just change number. See, similarly, so I2 equal to what now here? I2 equal to E2. Instead of E1 we can write E1, we can write E2 minus V, potentially same while in parallel connection. See here, by R1 means R2 we can take. It is the I2 value. So I2 equal to E2 minus V by R2, I1 equal to E1 minus V by R1. How to find out I1 here? See, first potential at A, VA, potential at E1, so means positive to negative, so we can take minus. Potential at R1, I1 R1, potential at B means potential at B is VB, so it will changes to this na VA minus VB equal to E1 minus, it is outside na plus, it is plus na minus, it changes, it will changes to this side means I1 R1. See here VA minus VB means V, E1 minus I1 R1. See, I1 R1 it changes to this side, so what we get? E1 minus V. So I1 equal to E1 minus V by R1. It is the current I1. So current I2 now. So second loop we can select A, P, Q, B. In this case, what we get now? Similarly, I1 place I2, E1 place E2, V place V, R1 place R2. We get I1 I2. See now here from this, what we can do now here? See. See, in parallel combination, see here I current is I, divided I1 I2. So means total current equal to sum of the individual current. So that's why we can write here I equal to I1 plus I2. I1 plus I2. See, instead of I1 we can write I1 we can write E1 minus V by R1. Instead of I2 we can write E2 minus V by R2. Yes na? See, I equal to E1 by R1 minus V by R1 plus E2 by R2 minus V by R2. See here, I equal to E1 by R1 plus E2 by R2 minus of V common. So minus V common now here, what we get here? 1 by R1 plus 1 by R2. Yes na? See here, it is, its v changes to this side, I changes to this side, means v into 1 by r1 plus 1 by r2 equal to e1 by r1 plus e2 by r2 minus I we can write. See here v na, here multiplied, changes that side means divided, means e1 by r1 plus e2 by r2 by 1 by r1 plus 1 by r2 minus 1 I by 1 by r1 plus 1 by r2. It is the, see v equal to e1 by r1 plus e2 by r2. Yes na, see by this one multiplied na, since this means divided, so 1 by r1 plus 1 by r2 I by 1 by r1 plus 1 by r2. Yes na, see here, so this one I write here, here separate directly I write here. Yes na, see this one here, how it is now, v equal to e effective minus I r effective. Yes na, like the IR is there na, so means here e means effective, means here what we can write, e effective equal to e1 by r1 plus e2 by r2 by 1 by r1 plus 1 by r2. R effective now here, what we can write now, 1 by r1 plus 1 by r2. 1 by r effective means what we can write now here, 1 by r1 plus 1 by r2. It is the 1 by r effective, it is the effective resistance. Yes na, see how now here, so we know here I1, how to get I1. So I1 means we took this loop, I2 means we can take this loop, so I1 equal to E1 minus V by R1, I2 equal to E2 minus V by R2. What is the sum of the current in the total current equal to sum of the individual current? Why? Because I current entered, it is divided at its both directions, I1 and I2, so means total current equal to I1 plus I2. So I write here I equal to I1 plus I2. I equal to I1 means here what, E1 minus V by R1, I2 means E2 minus V by R2, E1 by R1 minus V1 by V by R1, E2 by R2 minus V by R2. See, E1 by R1, E2 by R2 minus of V, what we get now, 1 by R1 plus 1 by R2. See, 1 by R1 plus 1 by R2 here, it will be changes to this side. So I changes to that side, means V into 1 by R1 minus 1 by R1 plus 1 by R2 equal to E1 by R1, E2 by R2 minus I. This multiplied now here, changes to this side means divided. I write separately directly. See, E1 by R1 plus E1 by R2 by 1 by R1 plus 1 by R2 minus of I by 1 by R1 plus 1 by R2. See, we have terminal voltage equal to effective EMF minus I effective internal resistance. So comparing here, E effective means this value, R effective means this value. E effective means E1 by R1 plus E2 by R2 by 1 by R1 plus 1 by R2. R effective means 1 by R1 plus 1 by R2. It will changes now. What we get now, 1 by R effective equal to 1 by R1 plus 1 by R2 means when cells are connected in parallel, that case what is the effective EMF now, E1 by R1 plus 1, E2 by R2 by 1 by R1 plus 1 by R2. Effective resistance means 1 by R effective equal to 1 by R1 plus 1 by R2. It is the effective EMF, it is the effective internal resistance when cells are connected in parallel combination. This case we can do problems. See here, for example, see, I can take here one circuit. See, it is connected in parallel combination. It is A, it is B. Here is a 9 volt minus 3 volt. This one it is 6 volt. Here it is 3 ohm, 3 ohm, 3 ohm. See here, this is the connection, means parallel combination of cells. What is the effective EMF? So see here, in this case effective EMF equal to, formula is E1 by R1 plus E2 by R2 plus E3 by R3 by 1 by R1 plus 1 by R2 plus 1 by R3. See here, what we can write now, E1 means 9 by 3. Here in a reverse, polarity is reverse. Polarity reversed means we can write minus 3 by 3. R2 is 3. Plus the polarity same. So means 6 by 3 by 1 by 3 plus 1 by 3 plus 1 by 3. 3 na, here 3, here 1, here 2. So means what we get na here, 3 minus 1 plus 2 by, here see LCM is 3, here 1 plus 1 plus 1 na 3, 3 3 cancel, 1 we get, means 3 minus 1, 2, 2 plus 2, 4 volt. What is the resultant EMF when cells are connected in parallel na? This case it is the EMF. Internal resistance na 1 by R effective equal to 1 by R1 plus 1 by R2 plus 1 by R3. See here 1 by R effective equal to 1 by R1 now here means 1 by 3 plus 1 by 3 plus 1 by 3. What we get now? R effective equal to 3 by 3 means 1. So means R effective equal to what now here? 1 ohm. What is the effective internal resistance now? 1 ohm. When cells are 9, 3, 6 are connected in parallel, but 9 and 6 are same polarity, 3 is opposite polarity, reverse polarity. In that case, what is the effective EMF now? 4 volt. Effective internal resistance is 1 ohm. Effective internal resistance is 1 ohm. See one more problem. What now that one? See, for example, say right here, see, it is 6 volt, its internal resistance is 1 ohm, both combination here, see, it is sorry, polarity is reversed here, it is 2 ohm, it is 2 ohm, it is 10 volt, it is 4 volt, 4 volt. This is the combination. So now here what we find out now? Effective EMF. Find effective EMF, E effective and R effective we want to find out. R effective and E effective. See here, first we find out parallel combination. So parallel combination now what? E effective equal to E1 by R1 plus E2 by R2 by 1 by R1 plus 1 by R2. E1 means what here? 10 by resistance na 2. Here polarity is reversed. Polarity reversed means we can write minus 4. Minus 4 by 2. Resistance is 2. See here by 1 by 2 plus 1 by 2. See here 2 ones, 2 fives. Here 2 ones, 2 twos. Yes na? So what we get? 5 minus 2, 3. By here resistance na LCM is 2. So means 2, 1 plus 1 na 2 cancel. So what we get na? Effective EMF equal to 3 volt. Effective EMF is 3 volt. Effective resistance na 1 by R effective equal to 1 by R1 plus 1 by R2. 1 by R effective equal to what now here? 1 by 2 plus 1 by 2 means 2 by 2. So means what we get now? Means R effective equal to 1 ohm. It is the effective resistance. It is the effective EMF for this circuit. See, this is parallel series to this one. We can write here. So means for this C, for this one, resultant is EMF is 3 volt, effective resistance is 1 ohm. Here plus 3 volt. Yes, now see I write circuit now again. See it is 6 volt. Yes, internal resistance is 1 ohm. It is plus 3. Plus 3 means same polarity. See here we can write 1 ohm internal resistance. It is 3 volt. Now see connected na effective EMF na here it is series combination. So effective EMF equal to what? E1 plus E2. Yes, E1 is what here? 6 plus 3 means 9 volt. So effective resistance na equal to what? R1 plus R2. So means what here? 1 plus 1 means 2 ohm. Means effective resistance is 2 ohm. Effective EMF is 9 ohm. See here this combination is parallel. This resultant is series to this one. So finally what we get? Effective EMF na 9 volt. Effective resistance is 2 ohms. Yes na? See next one is cells connected in series, n cells connected in series, sorry parallel, that we discuss. See if n cells of, I write problem first here. What is the problem now? If n cells of each EMF, is E and internal resistance R, and internal resistance R connected in series, sorry, connected in parallel, connected in parallel, then find then find effective EMF and effective resistance. We want to find out. See, n cells are in parallel means, see here, it is first cell, it is second cell, it is third cell, like this. Here in how many is there now? N cells are connected. See, these are connected in parallel. Parallel case. See here, parallel case now. It is the parallel case. Yes. See, it is parallel case. See, it is the parallel case. See means here it is A point, it is B point, it is EMF is E, E is there. Here R internal resistance is R is there. See, in parallel case now, effective EMF equal to E1 by R1 plus E2 by R2 plus so on En by Rn by 1 by R1 plus 1 by R2 so on 1 by Rn. It is the formula for effective EMF. See, effective EMF na E1 is what here? E by R plus E by R plus so what here? E by R. How many is there? N cells is there by 1 by R plus 1 by R plus 1 by R so on 1 by R. See this case na E by E na Ne by R, correct only na? Ne by R by here. See, 1 2 3 4, so how many is there? N. So N by R. See, R cancel, N cancel, means effective EMF is E. Means when cells are connected in parallel which are having same magnitude, that case net EMF is EMF of each cell. So means EMF of one cell. What is the EMF of first one cell? E. So that is the net EMF. So net resistance na, net resistance. See here means here net internal resistance. So net internal resistance means here R effective equal to 1 by R1 plus 1 by R2 so on 1 by Rn. See here 1 by R effective equal to magnitude is same na, 1 by R plus 1 by R so on 1 by R. How many is there here? 1 2 3 so on N is there. So means N by R means 1 by R effective equal to 1 by R. R effective equal to, sorry, N by R. Yes na? So R effective equal to R by N. It is the formula for when cells are connected in parallel, that case effective EMF is EMF of one cell, EMF of one cell. See, they are having same magnitude means E, one cell, EMF of one cell. So connected in parallel, that case what is the net internal resistance now? How many number of cells is there that have same magnitude means that resistance by number of cells means R by N. So means number of internal resistance is what here? N is there. So means N cells is there, N internal resistance is there. So that's why internal resistance is what? R by number of cells, number of internal resistance. Means here R effective equal to R by N. See, resistors are connected in parallel, they have same magnitude. What is the effective internal resistance na? Magnitude of internal resistance by number of resistors. So what here? N resistors is there. So that's why we can write R by N is the resultant of net internal resistance. What is the net EMF na? E only. What is the EMF of one cell? That is the net EMF when cells are connected in parallel, they are having same magnitude, they are connected in parallel. Such case effective EMF is EMF of one cell, EMF of one cell. Yes sir, that is the effective EMF. And effective internal resistance na, resistance by number of cells. So N cells na, so N, R by N. So that is the internal resistance. Yes na. Now see, this problem is very important. See here, if m rows m rows m rows contain n cells connected, n cells connected, n cells connected, each row N cell is there. Each EMF is E, and internal resistance R. Yes, na? Find first one. Find E effective. Second one. Find R effective. R external equal to R is connected to combination. Find, then find I, and I we can find relation between n, m, small r and capital R, and also find I maximum current in the circuit. That also we find out. It is called as mixed group, means cells in series, cells in parallel, both cases there. If m rows, see here, I write here m rows, see here it is one row, see second row. This type of how many is there? M rows is there. Each row contains how many cells na? N cells is there. N cells. See here one more. See, like this here how many cells is there? N cells. Here also see n. Here n cells is there. N cells. See here. Here na n cells is there. These are connected. See, it is B, it is A. See, these are connected in M rows and N cells. Each row contains N cells. This case, what is the effective EMF, effective resistance when it is connected to external resistor R? Then what is the current? What is the relation between N, this N rows, N cells, M rows, and internal resistance R, and capital external resistance R? That relation and I maximum we find out. For that, first see here. So first we can find out what is the net EMF in series case. We can write series. What is the net EMF in series? In series connection means each row contains what na? Series na? Series means what here? See this one. See, like this is there. How many cells is there? N cells is there. N cells means what is the effective EMF na? EMF, effective EMF is E1 plus E2 plus E3 plus so on EM. So means what we can write? E plus E so on. How many is there? N cells is there. So we can write effective EMF is Ne. So effective resistance na? Effective resistance equal to what? R1 plus R2 plus R2 so on. N is there. So we can write NR is the effective resistance. See, that means, see here, each row contains N, EMF is NE and resistance is NR. See here, I write in a circuit here. See, this is NE, internal resistance is NR. This is the circuit. This type of how many is there here? N is the M cells is there. Here see, it is the mth cell. Mth cell. Yes na? Mth row. Sorry, not mth cell. Mth row. See here, internal resistance. Like this na? It is the connection. Yes. M rows is there. Here middle is there. M rows is there. Yes na? See here it is Ne. It is NR. See parallel case na? What is the resultant EMF? Resultant EMF equal to parallel case effective EMF equal to EMF of each one. So any one cell. So means here Ne, here Ne is there. Means what is the EMF? Net EMF na? Ne. So effective resistance na is what here? Magnitude of resistance by number of cells is there. Means here number of cells means M rows is there. Means NR by M. It is the effective resistance when cells are connected in parallel. Effective EMF is Ne, effective resistance is NR by M. Why? Because each internal resistance is NR. How many is there? This type of M rows is there, M cells is there. So means NR by M is the effective resistance. effective EMF is Ne. Yes, now see here what we find out. Find I and relation between NMR, small r and capital R, and also find I maximum when it is connected to external resistance. It is the resultant EMF. It is the resultant resistance. So we can connect now here. For example, this I remove this one. Shall I erase this one? See here up to this. See here. Now I write here. See circuit I write here. What is the EMF now? Here see internal resistance is capital R. It is connected to external EMF. EMF is Ne. Internal resistor is N R by M. It is the circuit. Now it is the circuit. See current is moving this one. So what is the I value we find out? See here net EMF is Ne, net internal resistance is Nr by M, external resistance R is connected to this one, series and parallel combination. So this case, what is the I value now here? Net resistance, sorry, net EMF by net resistance, net resistance. See here, what is the net EMF now here? I equal to, net EMF means Ne, yes, by net in net resistance na this is internal resistance Nr by M, external resistance R, total na these are parallel connection means Nr by M plus R, it is the total resistance. So means internal resistance plus external resistance. Why? Because these are series connection means effective resistance equal to R1 plus R2. That's why R1 is what here Nr by M, R2 is R. We can write this is the mean. So from this what now we can simplify this one. See, if na Ne by Nr plus M capital R by M. So from that what we can write now? Current is MNE by N small r plus M capital R. It is the current passes through the circuit when M rows N cells means each row contains N cells which is connected to external resistor. That case what is the current across the external resistor? MNE by NR plus MR. MNE by NR plus MR. It is the current. So in this case what we find out now? What is the maximum current passes through the circuit? That one external resistor that we want to find out. For maximum case, what we can take now here? See, it is the main solution we are getting. What is the equation now here? Main equation I equal to, I write here again, I equal to M N E by NR plus MR. MR plus MR. It is the current passes through the external resistor. In this one, when it is maximum, current passes through the external resistor. For that, what now here see, it is the denominator value is minimum, definitely I is maximum. Denominator value is maximum, definitely I is minimum. So that's why we want maximum current. For I maximum current, for getting I maximum, what we are doing now here, denominator can be we considered as minimum value. So means NR plus MR, M capital R equal to we consider, we can take minimum value. So see here this one NR plus MR, I write it as, we can write it as what now here, root of NR minus root of MR whole square plus 2 root of NR M capital R. Like this we can write. Why we are writing now? Here see this expand now. Here what we get? Root NR whole square means square root cancel plus root MR whole square means square root cancel. What we get here? 2 root of N M small r capital R. Here plus is there. 2 root of N small m small r capital R. See this cancel. What we get here again? This one we get means this can be write it as like this. See here what we can write here, N R plus capital small m capital R equal to what we can write now, N small r minus M capital R whole square plus 2 M small r capital R. Like this we can write this one. See here NR plus MR is minimum. So means square means automatically tends to 0. So that's why we can take, see this value NR root of NR minus root of MR whole square equal to 0 means r value is minimum. For example, r square automatically very minimum na, so means r equal to 0.1, r square means 0.01, that means very minimum, so it is nearly equal to 0 na, that's why this term equal to 0 we can take. Square is changed, that side means 0, root nr minus root mr, in this one equal to 0, root nr equal to root of mr, so root cancel, so nr equal to mr means wherever small n small r equal to is there, mr we can write here. Now it is the formula actually. What we can write here, I maximum equal to what now here, mne by small nr is there, we can write capital mr, so means small m capital r plus again mr is there, so what we get here, mne by m 2mr to mr. See here m cancel, what we get now here, ne by 2r. What is the maximum current passes through the circuit? M rows, n cells are connected in series which is connected to external resistance, or that case I maximum equal to what now formula, n e by 2 capital R. It is the formula for I maximum. I na, it is the formula for I. Current passes to the external resistance is MNE by NR plus MR. These are the shortcuts for mixed group, means M rows, M is rows, number of rows, N is number of cells in each row, and R is internal resistance, capital R is external resistance, E means EMF. That case what is the current formula na, MNE by NR plus MR, M capital R. I maximum na what na, NE by 2R. This is the resultant for M cells, N rows connected in the series, and external resistance R is connected. See, it is very good, I think. Please see my videos, like the channel, subscribe the channel, and share to your friends and relatives. Thank you.